This conference will
Okay, so what we will be doing today is we will be talking about so in the last session we had a discussion on how we can represent various types of data. Okay, so we talked about numeric data, string data, boolean data, none type data. So we call them generally as literals. We call them generally as literals. Okay, so today we will talk about literals and data types, literals and literals, variables and data types. Okay, so literals, variables and data types. So we are going to talk about literals, variables and data types. So whenever I'm talking about literals, okay, so literals are nothing but the data members of the program. What are literals? Literals are nothing but the data members of the program. So the data members of the program, the data members of the program that cannot be updated, that cannot be updated. So the data members that cannot be updated. Okay, so cannot be updated in the sense, for example, so the value of phi, the value of phi is always phi. So you cannot increase or decrease, right? You cannot increase or decrease the place value or the face value of it. Yes, so it is fixed. So phi is always phi, 50 is always 50. So you cannot update it. So literals, so we have integer literals, we have float point literals, so we have character literals, so we have boolean literals and also non-literal. Okay, so the type of literals, the type of literals in Python are, okay, already we know them, but we'll just write once again. Integer literals. Okay, so what are they? Integer literals. And you have float point literals, float point literals, and you also have string literals, string literals, okay, and you have boolean literals, boolean literals, and you also have the non-literal. So you also have the non-literal. So non-literal. Okay. So what are the things that you have? Integer literals, float point literals, string literals, boolean literals, and non-literal, I should say, because it is only one. Okay. So integer literals means the numbers. Now, for example, if I say integer literal is like 4, 8, 0, 7. All these are integer literals. So when you talk about float point literals, it is nothing but 4.35, 5.97, 8.23, so 0.0. So these are all float point literals. So when you talk about string literals, they are like hello. Okay, so they are like, for example, Python. So like this, so you have which type of literals these are? String literals. What are these? String literals. So when you talk about Boolean literals, we have something like true and false only. True and false only. Okay, so then non-literal you have only one, which is going to be none. Which is going to be none. So that is why they are like fixed values. Their base value will never get changed. Their base value will never get changed. Okay, so now for example, if I put them in the program, okay, so if I put them in the program, now let's say I will open a Visual Studio, or I'll open a Spider, better it is. uh, right. So spider I can open. So in that, if I put the data, so now for example, I'll put one integer literal, I'll put one float point, I'll put one string, I'll put one true, none. So we can use them. We can use them for reusing. For reusing them, we require the next component called variables. What we require? Now, for example, if I am saying 5 plus 5, so 5 plus 5, obviously you will get 10. I'm not saying no. But I want to reuse. I want to reuse. Now I want to change this value. Okay, I want to change that value to 6. I want to change this value to 15. So in order to do that, okay, so now for example, if I am saying, let's say I am just saying 5 plus 5. So what is 5 plus 5? 5 plus 5 obviously is going to be 10. Okay, so 5 and 5, these are like fixed static values. Now what I want to do is in my next line of program, I want to change those values. I want to change those values. I want to update those values. If I want to update those values, what I need to do? Okay, so what I need to do? I need to go for variables. I need to go for what? Variables. So what is our topic here now? So as literals are constant, as literals are fixed, we cannot go for any updations on them, any update on them, any updates on them, and we can not reuse them, and we cannot reuse them. As literals are fixed, we cannot go for any updates on them, and we cannot reuse them. Okay, so now if I want updates and reusability, I will go for the variables. What I'll go for? Variables. So whenever I'm talking about variables, so variables are like placeholders. Variables are like placeholders. So they will hold the data. So they are nothing but the placeholders. They are nothing but the placeholders that hold the data, values. So they are nothing but what? They are nothing but the placeholders that hold the data values and acquire some memory. So they are nothing but which will hold the data values, and they acquire some memory. So they are nothing but the placeholders which will hold the data, and those will acquire some memory. So those will take up some memory from the RAM. Okay, from the RAM. Okay, from the RAM. So RAM means random access memory. Random access memory. Why I need this memory in RAM itself? Because that is not permanent data. This is not permanent data. So it is like temporary data. It is like temporary data. When your program is alive, it will be used. When your program is stopped or program is over, so it will be taken off. So that is why it should be in RAM. It should be in RAM. Getting my point? So the memory should be in RAM basically. Okay, so we can use it, we can reuse it, we can work with it multiple times also. Okay, understood? What are variables now? What are variables? They are nothing but the placeholders. They are nothing but the placeholders that will hold the values and acquire some memory, from the RAM. Okay, right. Now the variables can hold the data using the following syntax. So variables can hold the data using the following syntax. So what is the syntax here? The syntax is going to be variable name is equal to the name. Name should be given to the variable. Variable name is equal to data member is equal to data member. So variable is equal to the data member. So the data member means it can be integer data, it can be string data, it can be character data, it can be float data, it can be any data for that matter. It can be any data. So whenever we are talking about the variable, variable will hold which value? Variable will hold the data value, data member or the data value basically. Okay, so or the data value. Okay, so it is better to put it like this. Yes. Now data member or the data value is, now for example, I will say 55. 55 is what? Integer. Okay. 86.26, 89.26 float value. Okay, I'll say hello. What is this? String. It is a string. Now I will say false. What is this? It's a boolean value. Now I will say none. What is none? None means none value, which is nothing basically. So these are the data members. These are the data members. Now I cannot reuse them. I cannot reuse them wherever I want. Now, for example, if I want to add 55, every time I need to include this 55. So instead of that, what I will do is I will keep them in variables. I'll keep them in variables. So whenever I talk about variables, variables are the placeholders that will hold the data. Now, for example, I will say I is equal to 55. I is equal to 55. Okay. F is equal to 89.26. Okay. So, and hello is equal to yes. Okay. And here I will say boolean is equal to false. And here I will say n is equal to none. So now 55 is assigned into I. So 55 is holding the I value. 55 is holding the I value. So if you observe here, we are getting the B and we are getting the value. So don't worry about this middle one, I'll tell you that. So now what I'm trying to say at the end of the day, I created the variables. Okay, I created the variables. So what are the variables that I created? I created the variables and the values also I have given. Values also I have given. Okay, right. So now what I'm trying to say here, I'm trying to say that, okay, so let's put a table. Okay, so we will put a table here. So now what we observe here, so B is false. Okay, so B is false, F is 89.26, I is 55, N is none type object, S is going to be hello. Okay, so what we created, sir? We created the variables. What we created? We created the variables. We created variables. So as we created variables, how the variables are attached now? 55 went into I. So what happens literally in the background, I will become 55. F will become 89.26. S will become hello. B will become false. N will become none. Now this is the variable name and this is the variable value. All this F, S, B, N are called the names of the variables. Are what? The names of the variables. Names of the variables. So then what about that 55 and all? 55, 18.26, hello, false, none. These are values. These are what? Values. Getting my points? Am I crystal clear? So what are we talking about here? Creating the variables so that the variables can be reused. The variables can be reused. Now, for example, if I am saying increase the value of I by uh, 2 times. Okay, increase the value of I by 2 times. So what we can simply say? We can say I is equal to I into 2. I is equal to I into 2. So what I said here, you increase the value of I by 2. So what literally I said, I said, okay, so what I said here, I is equal to I plus I into 2. I into 2 means, what is I value? I value is going to be 55. So 55 into 2 is again going into I. 55 into 2 again, it is 110, right? It is 110. So 110 is going into I. So now what is I value? The fresh I value is going to be 110. The fresh I value is going to be what? Going to be 110. Understanding my point? So what we are doing here, we are increasing the value by 2 or doubling the value, simply say. So what we are doing, we are doubling the value. So how we are doubling the value? We are just saying I is equal to I into 2. So that I we are reusing, no? Understanding my point? So variable can be updated. Variable can be updated. So a variable can be, okay, we'll write the point. A variable can be updated. Variable can be updated or varied or varied. So it is updated or varied. So you can update it or you can say varied also. Means it is varying, no? So initially it was 55, now it is 110. Never say that 55 is changed to 110. Never. I value is changed from 55 to 110. So that is a point you need to remember. I value is changed from 55 to 40. So 50, I'm sorry, 110. So 55 is not becoming 110. I value is becoming 110. Say in that way. So never say 55 value is becoming 110. I value is becoming 110 from 55. So 55 was the initial value, and after some operation, the value of it became 110. Yes or no? Depending. That operation will depend on your requirements. Clear? So this is what is a variable for you. Variable may change also. So variable can be updated or varied. Now for example, so I is equal to I into 2. What is I value? I value is I value is going to be 55. But what we did here? I value is 50, I value is 55, no? I value is 55. What I did? I is equal to I into 2. Who is I value? I is 55. 55 into 2. So what is 55 into 2 now? 55 is into 2 is going to be 110. So I value will become 110. So it can vary. It can vary. So in that way, we talk about the variables in Python. Variables in Python. So variables, we don't require much more information. So we just say A is equal to 5, B is equal to 8. That's it. So 5 is going into A. 5 is going into J. So now, for example, if you are saying A plus B, what will happen? 5 and 8 will get added. 5 and 8 will get added. Okay, is that clear? So this is how we deal with the variables. We deal with the variables. Okay, now we got the idea of literals. What we got now? We got the idea of literals. Where the literals will store? Literals will store in the variable. Where the literals will store? Literals will store in the variable. Fine. Up to now it's okay. Literals are there. So what kind of literals are there? Numeric literals, that is integer literals, float point literals, character literals. So all these literals can go and sit in variable, and variable can change. All these properties are okay. But along with this, every literal will belong to a particular type. Every literal belong to a particular type called the data type of the literal. Data type of the literal. So what data type will say? Data type will say that, hey boss, you are of this type. You are of this type. So what it will say? Hey boss, you are of this type. So this type. So you belong to this type of data. You belong to this type of data. You are getting my point? So you belong to this type of data. So like that, we have the next concept as the data types. Data types in Python. Data types in Python. Okay. Every data value will have a type. Always remember this. Every data value will have a type. So this type is something like, now for example, there are 100 students. So now in that there are 5 batches, like say MPC, MEC, CEC, intermediate students, MEC, CEC, HEC, and all. Okay. So now I'll take 5 people. Now I'll ask them which batch you are. So what they will say? They will say we are from MEC. Means they are of type MEC. They are of type MEC. Same thing here. Now for example, if I am just picking out, I'm just picking out 459, 897. So they will say we belong to a particular class. I'll give 4.3, 4.2. They'll belong to a particular class. So 30, I mean, hello, welcome, all these belong to one class. True, false belong to one class. So like that, we have data types. We have data types. What data type will tell you? Data type will tell you the type of the data. Data type will tell you the type of the data. Getting my point? Okay. They will convey the type of the data. They will convey the type of the data. So what data types will do, sir? They will convey the type of the data. They'll convey the type of the data. Yes. Okay. So what data type is given to a particular variable? They'll convey the type of the data. Okay. Every literal will have a data type. Will have a data type. Every literal will have a data type. Okay, right. The data types are put into the data types are put into two major categories. The data types are put into two major categories. Okay, so the data types are put into two major categories, right? So what I'll do here is I will say the first one, single valued data type, single valued data types. Okay, and you also have the second one, which is multi-valued data types. Single valued data types, and second one is multi-valued data types. Single value data types, and second one is going to be multi-valued data types. Is my point clear? So what is the first one? Single valued data types. What is the second one? Multi-valued data types. Concept is clear? Okay. So when we talk about single valued data types, so these types will contain the single value based data elements. Single value based data elements. Data elements, you can say, data objects, you can say, no problem. Okay, right. And what about this? These types will contain the multi-value based data elements. So these types will contain the multi-value based data elements. So multi-value data types, these types will contain the multi-value based elements. So whenever I am talking about multi-valued elements, multi-valued means multiple values. Maybe 10:30. Lele cockroach. So these types will contain the multi-value based data elements. Multi-value based data elements. So these types will contain multi-value based data elements. This type will contain single value based data elements. Right? So multi-valued, single value. Now, under single valued what will come? Under multi-valued what will come? We will see. Okay. So we will insert a table. Insert a table. So in this table, we will have single value data types and we will have multi-valued data types. Okay, single value data types and you will have multi-valued data types. Okay, under the single value data types, again you have some categories. Okay, so first one is going to be numeric category. So what is the first one? Numeric category. So under the numeric category, you have int, you have float, so you have complex. Okay. So what are the three things that you have here? Int, float, and complex. Int, float, and complex. Okay. And next one you have under this is Boolean category. Boolean category. So under this you have the Boolean category. So under the Boolean category you have only one, which is bool. Which is bool. You have only one. What is that type? Bool type. Bool type. Okay. Yes. And the third one you have is none category. The third one is none category. So none category we will call it as none type. None type. Okay. So none category you have none type. So for your understanding, you can see this, right? So str you can leave, all the others we can take up. Now if you observe here, okay, so what you observe here, so b bool, okay, so b small actually, so b bool, okay, so b bool, so b is of what type? Bool type. It is false. Size is what? 1. What I told you, single value, single valued data types. You might be saying, sir, false false, no, false is only 1. So false is like collectively 1. Clear? Okay. So next float, this also is 1. Int 1, so this also is 1. So none type, this also is 1. Okay, so none type, int, float, bool. Okay, complex also I can create. So complex something like 3 minus 2j. So 3 minus 2j, I will say something like, okay, c is equal to, so c is equal to 3 minus 2j, and if you observe here, so it is going to be complex data. Okay, so it is going to be complex data. So what you observe here, so we got the complex also, no? Yes, so we got the complex also. Okay, otherwise I'll cut everything and paste at once. Okay, so right, so what we are looking at here, we are looking at what types? None type. None type means no value. None type means no value, nothing basically. Int 110, float 89.26, complex 3 minus 2j, bool false. So these are what? These are the single valued data types. Single valued data types. So they will have only a single value. They will have only what? Single value. Is that clear? Paka? Right. So then we will go for multi-valued data types. So multi-valued data types, again you have some categories. Okay, again you have some categories. So the categories are, first you will have sequential or multi-valued. So you have what? Sequential data type elements. Sequential, okay, otherwise I'll say sequential category. Sequential category. So you have only so you have many. Under that, the first one is going to be sequential category. Under the sequential category, the first one is going to be str. First one is going to be str. So where you saw str just now, you saw it here. Yes, s is equal to what? S is equal to str, and number. What is the number here? You have seen. You are seeing 5. What is that 5 means, sir? 5 is nothing but collection of these values H, E, L, L and O. So collection of that 5 values, right? Understanding my point? So str is a collection of the 5 values. S, which is nothing but str. Str, how many values? 5 values. What are they? Hello. H, E, L, L, O. Is the point crystal clear? str. So for now we will only see this. We will be creating others later, but we will be listing them out. We will be listing them out for sure. So second one under the sequential is list. Under the sequential comes list. List is a collection of elements. List is a collection of elements. List is a collection of elements. Okay. So collection of all the elements. Collection of all types of elements. So you can have a collection of all types of elements. Okay. Right. So next, tuple. So tuple is similar to a list, but definitely there are some differences which we will be seeing later. Yes, definitely there are some distance. List and tuple are both collection of elements, but there are some differences that we will observe later, not now. Okay, tuple, and then you have range. What do you have? Range of elements, range of elements. So I will go for some range of elements, range of numbers, range of elements. Clear? So under sequential, what are there? str, which is nothing but string. List, collection of all types of elements. List is also collection of all types of elements. Range is numbers in a sequence. Numbers in a sequence. That sequence we can provide. Is my point clear? Okay. This is sequential category. Then comes set category. Okay. Before set category, we can go for byte category. Byte category, not very much useful this byte category, but still you have to know. So bytes, and you have byte array, byte and byte array. Okay, so what all they we will see, but for now I will tell you that they are the collection of elements from 0 to 256 only. They are collection of elements from 0 to 256 only. So we will not have less than 0, and we will not have more than 255. Okay, values range from 0 to 255 only. Is that clear? Okay. Then you will have set category. The next category, set category. So under the set category, you have again two sets, and you have the frozen set. Okay. So under the set category, you have two. What is the first one? Set, frozen set. Sir, what is the set category, sir? Set category is again a collection of elements, but without duplicates. So this str, now for example you see hello, l coming two times, right? Now for example if you write the same thing as a set, l comes only one time. Why? Because set will not contain duplicate elements. Set will not contain duplicate elements. Okay. So frozen set and set something similar. Again, like list or tuple, we have some differences. We will look at them later. Is that clear? Okay. So set category. So then comes finally map category. The next category, map category, where you have only one thing, which is dict. Which is what? Dict. Dict means dictionary. Dict means what? Dictionary. So dictionary means, I'll just give you idea. Now for example, one, I will say 1 pointing to 1, 2 pointing to 2, 3 pointing to 3, means we are creating a collection of elements. Okay, collection of elements with a pointer. So this generally we will call it as key value combination. What is that? Key value combination. So here 1 2 3 are keys, one, two, three are the values. So what are that keys, what are that values, all that story we will be dealing with later. So for now what you need to understand, what are data types. So data types are nothing but the types of the data. So data types are nothing but the types of the data. So the types of the data means, types of the data means, uh, if you are providing the data, so it should say that I belong to this type, I belong to this type, I belong to this type. Now for example, if I'm creating 5, 5 belongs to int type. Suppose if I'm creating 3 minus 2j, it belongs to complex type. If I'm creating true object, it belongs to boolean. If I'm creating hello, it belongs to str. If I have a collection of things, it can be a list, it can be a tuple. If there is no duplicate allowed, it can be a set. If there are numbers between 0 to 256, then it is byte. If it is dictionary, it is a key value pair, so all the data will be bounded with this only, types only. So there are nothing other than this. Am I clear? So whenever we talk about the data type, the data types are nothing but the types of the data used in the program. Point number one. Point number two, there are two types. What are they? Single valued and multi-valued. So single valued means they can hold only a single value. So the single value can be an integer, can be a float value, can be a complex value, can be a boolean value, can be a none value. So whereas when you come to the multiple or multi-value, you have sequential category, where you have a string, where you have a list, where you have a tuple, where you have a range. Okay, all these are sequential in nature, Okay, next, byte category. Byte category is also sequential in nature, but they can hold only values from 0 to 255, nothing more than that. Okay, next, set category. So under set category we have only two types, set and frozen set. Next, map category, you have dictionary. Dictionary will have, suppose now roll number is there, your roll number is associated with your name, right? So your Aadhaar number associated with your name, so like that. Key value. So these are the things that we need to know as the data types, got the clarity now? Okay, so first we will start with numeric category. Okay, we'll start with what? Numeric category. So whenever I'm saying numeric category, the representation of numbers. Okay, representation of numbers. Okay, representation of numbers. So first we will talk about int. So directly I'll give you the example. So when I say, now for example I'm saying x1 is equal to 58. Okay, now simply what I'll say, I will say type of x1. What it will give you? It will give you int. Means what we are asking the system, hey, what is the type of x1? What is this type? Type is a function. Type is a function which will do a task. What is the task of type? The task of type is to fetch the okay. So what is this? Type is a function. Okay, I'll write that point. Type is a function that the type is a function that retrieve the type of the data value. Retrieve the type of the data value. So what is this? What is x1 now? X1 is the type. X1 is the type. So x1 is the type of x1 is of which type? X1 is of integer type. X1 is of integer type. Is my point clear? Integer in short we call it as int type. Yes, point is clear. Okay, now let's say I have a decimal point number. Okay, so I have a decimal point number. Let's say I have x2 is equal to 3.25. Okay, and I'll say type of x2. Now tell me what happened. Why? Because 3.25 is of which type? Is of the float type. 3.25 is of which type? 3.25 is of the float type. Is that clear? Directly you are getting float now. How? Because it is of that type. What is type? It's a function. What a function will do? Function will return something. Function will return something. Yes or no? The function is returning what? It is retrieving the type, or it is returning the type. It is returning the type. Okay. Right. So next we will see complex. So what is complex, sir? Complex is nothing but something like x3 is equal to 2 minus xj. So what is type of x3 now? Type of x3 is going to be the complex type. Which type? Complex type. So whenever I'm trying to talk about the or I want to retrieve the types, means I can go for the type. I can go for the type. Is that clear? Okay. Now the interesting point over here is conversions. Okay. So conversions of numeric types. Conversion of numeric types. Now let's say I want to convert into two floats. I want to convert into two floats. Right? So what I need to do, I need to say float of int value. Means what is float here? Float is a function. What is float? Float is a function which will turn an integer value into float. Okay, function turns an integer an integer value into floats. So a function turns float of int value function turns an integer value to float. Now for example, I have something like I is equal to 89. Now what I'll do, I will say float of who is I is the integer value. Now what I'll get, I will get 89.0. What I will get? 89.0. Why 89.0? Because I value is 89. Float of I means it should give you. So if you remember, I told you integer part, this integer part, decimal point, and the fractional part. So we don't have any fractional part over there, so that is why it is becoming 0. Getting my point or not? Okay, so something like, now for example, I is equal to 89. Now I will say j is equal to float of I. Now what is I value? I value will be as it is, and if you observe the j value, the j value becomes 89.0. Why sir 89.0? Just now I told you, right? So as I told you, it will become, what it will become? It will become 89.0. 89.0. So I is equal to 89, j is equal to float of I, print of I. What is I value? I value is 89, j value is 89.0, because it is the float version of I. It is a float version of I. Is that clear? Okay. Now, this is what happens when you are converting what to what? Into to float, right? Next one. We will convert float to int. Float to int. Okay. What comes up here? So what comes up over here? So you can see int of float value. Int of floats value. So float of int value. Now here int of float value. Function turns and turns a float value into an integer. So it turns a float value into an integer. Now for example, I will have something like k is something like, let's say, 59.37. Okay. Now int of k. Now what happens, this is integer part, this is decimal point, and this is the fractional part, as you know. Now integer contains only one part. What is that? Integer part. So only 59 will come. 0.37 value is lost. 0.37 value is lost. Is that clear? So simply speaking, so if I am saying something like k is equal to 89.37. So here I will say int of k. Int of k. So if I am saying int of k, the value of k no change. The value of j will become what? Will become 89. Why sir? Why like that? Because the fractional part is gone. The fractional part is gone. Is that clear or not? So this is how we deal with the conversions. Conversions become very important later, right? Complex conversion, we are not worried, because it is not important in the real time also, and it is not useful also. That is why I'm not going to make any complex conversion. Okay, it is possible to have that, okay, but we will not follow it. So it is unnecessary. Yes or no? But float to int conversion and into float conversions are important. Yes, and of course string conversions also can be done, that I'll show you later. Is that clear? Okay, so that's how you look at the things, right? So what all things we understood today? We understood about the literals, we understood about the variables, and we listed out all the data type, and talked about the numeric category. So numeric category means complex numbers. So complex numbers you know already, right? So what are complex numbers? 2 minus 6j. Okay, real part and the imaginary part. So next boolean is like true or false, none is like nothing. So you have sequential, under that you have str, you have list, tuple, range, etc. Okay, and no, not etc, only that. So byte category, bytes, byte array, set category, set and frozen set, map category, you have dictionary. Okay, and I also told you about the conversions, how we can convert and what happens in the background. Okay, so that I already told you. Okay, so that's it for this session. So we'll meet with the other discussions of the other data types, right? Thank you.